Okay, so this is the fourth section in chapter 3, dealing a bit more with the periodic table. We talked before about metals. Metals make a huge part of the periodic table. Non-metals don't make as big of a part, but they have the most variety, so you can separate them and even separate them into families and talk about them that way. But in general, the physical properties of non-metals, they are poor conductors of electricity and heat, which is often why they are more insulators than they are conductors. Excuse me, they're dull and brittle. They are reactive with other elements and make a lot of compounds out of those found in the alkaline metals and the alkaline earth metals, and then things found on the opposite end of the periodic table make a lot of compounds that way. Most of them are gases, which means they have much lower densities than metals, because gases are way less dense than metals are. Some examples here, we've got helium gas in a blimp. Sulfur crumbles into a powder. We've probably had sulfur before, like I said, they're good conductors. Carbon compounds are found in plastic insulating these copper wires. So those are some very specific general properties of physical properties of nonmetals. So the main chemical property of the nonmetals, like I suggested before, is that they form lots of compounds. They do that by gaining or sharing electrons in this case. So they either take an electron from something, they'll usually take electrons. And if they don't take electrons, then they'll share electrons with something. I'm going to get a lot into that in this section as far as how those things work and bonding. We're going to get into that even more later, but just to give you the basics of how this all works. I kind of mentioned in the last section about electrons, and electrons are a big part of how things bond. They share electrons or they transfer electrons, and that magic number is 8. Or they always want 8 to be happy. So if they have 8 that they've got in their outer shell, then they are happy. So whether they share those or they pass those off to something, whatever it happens to be, they want to have 8. So we're always looking for 8. And again, here's a really good example, sodium and chlorine. Sodium is an alkali metal. Chlorine is what we call halogen. We'll get into that later. This has 7 valence electrons, or 7 bonding electrons. This has just 1. So it will pass its extra electron off to this to give this 8, and then this doesn't need to worry anymore because it's lost its main electron, so it's going to be fine because all the rest of the levels of electrons are full, so it's super okay. But then again, that's how they form their bonds. So very, very, very commonly form these types of bonds. Okay, so as I suggested earlier, we get into families here. We don't talk about, in general, nonmetals. We talk about their families. So this is called a carbon family. Notice carbon is the only nonmetal in this family. Carbon is a solid. It's also a solid nonmetal. It's a black solid in its own elemental form. If you have really, really, really like high-pressured carbon, it will turn into diamond. But for the most part, it's kind of this black solid. There's also a couple metalloids, and then I talked about the metals in mixed groups. These are a couple of metals in mixed group, tin and lead. This is where it is found on the periodic table. So here were the alkaline metals, alkaline earth metal, transition metals. I'm going to go over to group 14, which is the carbon family. We name these families off of the element that is at the top. The one that's at the top. So because carbon is at the top of the family, it's the top row up there, we call it the carbon family. It's group 14, which means they gain or share 4 electrons. One thing about carbon that makes it pretty cool is that it likes to share, and it shares with itself a lot. So a lot of carbon molecules are created when we talk about carbohydrates, proteins, lipids, the basis of a lot of our food is made by carbon chains, because they link together very well and they hang together very well. So they make these really long chains that are a big part of the foods that we eat. Okay, next we have group 15, which is nitrogen. It's a nitrogen family, I should say. Here we have a couple nonmetals. We have nitrogen and phosphorus, and nitrogen is a gas, phosphorus is a solid, and then we have a couple metalloids, which we'll get to. And then last we have one metal in this group, and they are right here, group 15. So they either gain or share 5 electrons. You might have seen, maybe by 2 of these slides, you already see a pattern developing here, whereas the group 14 had 4 electrons to gain or share. This group 15 has 5 electrons to gain or share. We talked about group 1 that has 1, group 2 has 2. So kind of seeing a pattern based on the families. And in this part, it's the ones place, since they're all groups that are higher than 10. So things like nitrogen, which we've talked about before. Nitrogen is a big part of basically growing things. Plants use nitrogen and they fix the nitrogen. So when we eat the plants, we get our nitrogen our bodies needs that way. Nitrogen gas is a huge part of our atmosphere, but our bodies don't use it in the gas form. We have to use it in solid forms in plants. Phosphorus, if you've ever lit a match before, phosphorus is a big part of that compound that basically helps to light the match as well, the tip of that. So those are a couple uses for those two particular elements. Okay, so group 16, oxygen family, which again, oxygen is at the top of the family. We call it oxygen family because of that. It gains or shares 6 electrons. 6 is in the ones place, 6 valence electrons, or 6 electrons for sharing or gaining. Anyway, so it's got oxygen and sulfur and selenium, oxygen being a gas, and then sulfur and selenium are solids. Then we've got tellurium and polonium, which are 2 metalloids. Oxygen, that's a huge part of our atmosphere. We use it for breathing. We use it for respiration in our case. Rubber contains sulfur. I don't know a lot of uses of selenium, but here's some different. And so these elements, there's lots of different uses for most of them, but oxygen being the most important one in this case. And notice again, group 16, gain or share 6 electrons. So again, part of that pattern we've been talking about. Okay, next we have halogens. Halogens are group 17. Notice it's not called the fluorine family, it's called the halogens. Halogens, basically they're very reactive, very similar to the reactivity of those of the alkali metals. In fact, a lot of halogens make a lot of compounds with those found in the alkali metals, which is group 1, things like potassium and lithium and things like that. So fluorine and chlorine are 2 gases. Then we have bromine, which is one of our liquids on the periodic table, along with mercury, which is also a liquid. And then we have iodine and acetine, which is a metalloid. But the rest of these are all nonmetals. So again, a big part of these groups, or these families, being nonmetals. Fluorine is a big part of fluoride treatment at your dentist. A lot of those are found in the compounds that contain fluorine are found in toothpaste and whiteners and things that you will use at your dentist's office for those reasons. Chlorine, you've probably been to the pool before, and chlorine makes up something that basically takes the water that you're in and it makes it it has a chemical in it that basically kind of kills all the yucky stuff that might be in the water. Bromine is also another way of doing that. It's a little bit more expensive, but bromine is also another thing you can put in the pool to kind of cleanse it. And bromine is a liquid at room temperature as well. Iodine is another thing that a lot of times it's used in more medical type procedures. But again, 17, they have 7 electrons, very reactive, so 17, 7, that's another one of those that goes with the pattern that I've been talking about. Okay, so group 18, noble gases. Noble gases have 8 electrons. Remember when I said 8 is that magic number? Well, there you go. They've got 8, which means they don't want to mix with anything. They don't gain or share electrons. You're not going to find these in compounds, hardly ever. They are called noble because a long time ago, nobility didn't mix with anything else. They just kept to themselves, which is what noble gases do. They keep to themselves. They don't mix with other things. So these are all gases in this family. It's the very far right side of the periodic table. We have helium, neon, and argon, and krypton, and xenon, and radon, all noble gases. Helium, we know lots of uses of helium, balloons, things like that. Neon, have you ever seen a neon sign before? Argon also is used, so is xenon. I think krypton a little too. Those are all can be used in what we call neon signs. These gases glow different colors, which means they're good for when you heat them up, they glow, which makes signs look different colors if you use a lighted sign. So they're useful in those cases, but again, they don't form compounds. They hang out by themselves in the atmosphere, so we have trace gases of these all over the place, not in any sort of compound. And group 18 don't gain or share electrons, don't form compounds. Always have to mention hydrogen here because hydrogen is on the left side of the periodic table. Even though it is a nonmetal, it sits up above group 1. It isn't attached because the only reason why is because it only has 1 electron and 1 proton. And so just like everything else in group 1, it has 1 electron, which means it forms a lot of compound hydrogen gas. Most of hydrogen on Earth is found in water because it forms a liquid called H2O, or water, when it comes in contact with oxygen. They used to try hydrogen gas as something that they could put in balloons and things, or like big balloons actually, because it's a very light gas, it floats. But the problem with it is it's flammable, and so it's not really used. Have you ever heard of the Hindenburg before? Those blimps that were used a long time ago. A lot of times they used hydrogen in those until they realized, oh, it burns, and it's not very safe, so they quit using it. But it's on the left side of the periodic table. Okay, the metalloids, I've kind of talked about them a little bit, but they're not specifically, I didn't really talk about much. These are found in the staircase, and it's a little staircase that forms in between the metals on this side and the nonmetals on this side. They're called metalloids because they have some characteristics of metals and some characteristics of nonmetals, which makes them good for being semiconductors, because sometimes they will conduct electricity and sometimes they don't conduct electricity. But an example of one are silicon. Silicon is a good example of a metalloid here in this case. And that is, as far as the nonmetals go, that's all of them. A lot of different characteristics that go on there, a lot of different compounds that are formed. In this case, I'm going to talk about the periodic table just a little bit more in this section as well. Okay, so one more periodic table lesson here. I'll talk about it a little bit more. Now I've gone through basically everything in the periodic table. So I started over here in the metals. First up we talked about were the metals, and then we talked about the nonmetals and the metalloids, which are here in yellow. We talked about how the lactonides and the actinides go down below, because otherwise it gets too wide. It can't fit on a page in this case, or 2 pages in this case in our book. All of these that are white means that they were created in a laboratory and not found in nature, which means they used a particle accelerator to create them. And as soon as they're formed, a lot of times they begin to break down and are not necessarily useful for anything. We talked about those in group 1 here, called the alkali metals. They only have the 1 electron, which means they form compounds very easily, very highly reactive. Group 2 are the alkaline earth metals. And again, fairly reactive. They form lots of compounds. And we have the transition metals here in the middle. Those transition metals are fairly non-reactive, and they kind of act very similar. So they don't necessarily fit part of that pattern. Then we go to group 14, where we gain or share 4 electrons. Group 15, gain or share 5 electrons. Gain or share 6 electrons, 7, 8. So that's how this works. These are the amount of electrons in their outer shells, so how they're able to bond with things. We talked about how these up and down columns are called families or groups. Those that are going across are called periods. There's atomic symbols, and there's atomic mass, and there's atomic number, and all those have been gone over. So this is kind of like a huge part of the periodic table. I might have just another lesson on the periodic table that I put up as a lesson just to listen to in case you have get a little bit more in depth with things on the periodic table. I feel like I've done a lot, but I usually spend a lot of time in class on the periodic table, and I don't necessarily have that opportunity this year, so I kind of want you to really understand it. There will be homework on this. I believe it's part of the packet that went home. And you can either print it off if you don't have that packet, or you can look at the packet that you picked up and it's in there. You can look on PowerSchool Learning. You can just do it on a separate sheet of paper and take a picture of it or hand it in on the next due date. Those are all the things. This is not due until the middle of April. So I love the periodic table. Hopefully you've got some understanding of this. Like I said, I might put a complete lesson up that's just about the periodic table and break it down a little bit further for you if you have any interest in that. And enjoy!